In this video, we're going to talk about piecewise functions, which are two or more equations that are combined over a specific domain. So we'll look at how do we evaluate piecewise functions, write the equations, and look at the graphs. And we already talked about domain and range for piecewise functions, and graphs with asymptotes that have multiple components in a different video, and so that is going to be linked right here. So go ahead and take a look at that if you need to look at domain and range for piecewise functions. So one way we can look at piecewise functions is take the absolute value function, which we should be familiar with, and we can actually break that up into two different functions. So first off, if we just take the right side of our function where x is greater than 0, if I extend that line to go forever, that just gives us the linear function with a slope of 1 and y-intercept of 0, which is basically just y equals x, right? So that's what this represents here. F of x equals x here. Well, if we look to the left, where x is anything less than 0, and we extend that component forever, that gives us the linear function with a slope of -1 and a y-intercept of 0. So that's y equals negative x, or f of x equals negative x. Well, these two components don't continue on forever, right? They both stop at 0, and the other one continues. So f of x equals x when x is greater than or equal to 0. So we have this condition here where x is greater than or equal to 0. For this component here where f of x equals negative x, that only works for x less than or equal to 0. But you see that this only has less than 0, not less than or equal to. Well, if x is 0, it actually gives us the same output for both of these functions, but we can't have x equals 0 contained in both conditions because we don't know which one to use. It's not always going to give us the same value. So we can only pick one. So we just have x greater than or equal to 0 here. This could be less than or equal to 0 with x greater than 0 here, just as long as it's only listed in one of them. So this is how we write a piecewise function, where f of x is equal to more than one function with a given condition based on what our x value is. So looking at another example here, this is kind of a partial absolute value function and a partial quadratic function. And so, well, that's not what I wanted. Delete that. So this function here, if that were to go forever, would be negative x squared plus 6. So it's been shifted up 6, and it's reflected down. This component here, if it went on forever, would just be the absolute value of x minus 2, where it's shifted to the right 2. But we have to put some conditions on it, right? So this first part here is only from negative infinity up to and including 1. That's what this filled in circle means. So when x equals 1, this dot here, this filled in dot, tells us that is part of the graph. But for this component here, this open circle tells us that the graph goes up to 1, but doesn't include 1. So this case is everything greater than 1. So if we look at the domain and range for those two, our domain is from negative infinity up to 1, including 1, so we use the bracket there. And that's the union with from 1 to infinity, not including 1, which is why we have the parentheses there. So it really contains everything from negative infinity to infinity along our x-axis when we combine the domain for both of those. Our range goes down to negative infinity and then up to 6 for this component here, right? So negative infinity up to and including 6. And then for this function, it starts at 0 and it goes up to infinity. So this is the domain and range for our two functions combined. Well, that ends up giving us a complete domain in our piecewise function of negative infinity to infinity, or we can say all real numbers. And for the range, we just combine it and we go from negative 6 up to, negative infinity up to, that should not be 6, that should be infinity right there. And we know infinity always has parentheses. So the domain and range are both all real numbers. And then our complete piecewise function here is going to be these two functions here. So f of x equals negative x squared plus 6 when x is less than or equal to 1. So at 1 here and everything less than 1, so going to negative infinity, we use this function, and then we use this function for anything where x is greater than 1. So last example here, we're actually going to evaluate a little bit of what we have in this piecewise function. So if we evaluate these examples here, g of negative 2, well, that's telling us x is negative 2, and x is negative or less than 1 in that case. So if x is less than 1, then we always get an output of 4. So g of negative 2 is equal to 4. Okay. If x is 1, well, that is this condition here. So then we use g of x equals 2x. So we do 2 times 1. G of 1 is equal to 2. And then the last one, g of 3. Well, 3 is also greater than 1. So then we do 2 times 3, and we get 6. And so those are different outputs based on these inputs here. Now, if we want to sketch g of x, well, for anything less than 1, we have g of x equals 4. So we've got this horizontal line that's basically y equals 4 when x is less than 1. So we really need an open circle here. I'm just going to put a little dot there. So an open circle, so everything less than 1, we get an output of 4. And then for g of x equals 2x, well, that's a slope of 2 with a y-intercept of 0, but that's when x is greater than or equal to 1. So we have a closed circle at 1 going on forever to infinity. So now we've sketched it there, and then our domain and range would be all reals for domain, because once we get to x equals 1 here, it immediately starts up again here, goes to infinity, and the range, it doesn't go below 2, and it goes up to infinity.